Monomers and polymers. So, monomers are the building blocks. Have you ever played with a toy called Legos? I want you to think about Legos. These are the little bricks. You can use these little bricks to build things like you can build a house, or you can build a car, you can build a dinosaur. The individual blocks, we can call those monomers. But if you take those blocks and you build a Tyrannosaurus Rex, a big dinosaur, the dinosaur would be the polymer. A polymer is made up of many small, similar blocks called monomers. And this is actually how biological molecules are made as well, except for lipids. We'll talk about lipids in a little bit. So, how do we join together monomers to build a polymer? Well, there's two reactions that we're going to learn about with monomers and polymers. If we want to join together different monomers, or even if we want to join together polymers, we're going to use something called a dehydration reaction. Hydra means water, and de means not. So dehydration means a reaction that takes away or is not water. This is actually a reaction that's going to remove water. And when it removes water, it joins together the two monomers to form a polymer. The opposite of a dehydration reaction is a hydrolysis reaction. A hydrolysis reaction is when we're adding water, so hydro means water, and lysis means breaking. So hydrolysis or hydrolysis means water breaking. We're breaking the molecule using water. And both dehydration reactions and hydrolysis reactions are mediated or helped using enzymes. And an enzyme is just a molecule that helps to make a reaction happen more quickly or more easily. It lowers the activation energy. If you've learned about catalysts in chemistry class, an enzyme is the same thing as a catalyst, but in biology, we call them enzymes. They're usually proteins. So let's look at an example here. So a polymer like this is just a small polymer, but it's still made of many pieces. And this is an unlinked monomer. So we have a polymer and a monomer, and we want to join them together. Well, we can do that quite easily by doing a dehydration reaction. In a dehydration reaction, we're removing the hydrogen atom from this side of the molecule, and we're removing the hydroxide from this side of the polymer, and they join together to form water. And when they join together, these monomer and polymer pieces will also join together. The water leaves, so we are dehydrating, we're taking away water, and we're forming this polymer. Now, what if we want to break this molecule? Well, that's easy. We just add water. We do the opposite. This is called hydrolysis or hydrolysis. So take a breath and say this after me. Hydrolysis. Okay, you sounded really great right there. Perfect pronunciation. So hydrolysis, using water to break apart this polymer. And in the end, we get a short polymer and a single monomer. So this is how we are building and breaking biological molecules: dehydration reactions and hydrolysis reactions. Now, moving into our first big category of biological molecules, the carbohydrates. See these bees, they are making honey. What's the connection with carbohydrates here? Well, carbohydrates can be anything from small sugar molecules, these would be the monomers, and we call carbohydrate monomers monosaccharides. A big carbohydrate is called a polysaccharide. Saccharide means sugar. So mono means one, and saccharide means sugar. So monosaccharide means one sugar. Poly means many. So polysaccharide is many sugars. So this is a question you will probably see on the test. What is the monomer of carbohydrates called? Monosaccharides. What are the polymers of carbohydrates called? Polysaccharides. Monosaccharides always have a formula that is some multiple of C, H2, and O. They contain both hydroxyl groups and carbonyl groups.